2026 A-Level Combined Mathematics Paper 1 Part B Question number 13 Part C. Parts A and B of the same question were discussed in previous videos, links in top right. Part C of this question has to do with complex numbers and De Moivre's theorem. The question says, show that cosine of alpha plus I sin alpha divided by cosine of beta plus I sin beta is equal to cosine of alpha minus beta plus I sin of alpha minus beta, where alpha and beta are both elements of the real numbers. The question then says, express 1 plus root 3i and root 2 times 1 plus I in the form of r times cosine of theta plus I sin theta, where r is some value greater than 0 and theta is some angle in between negative pi and pi radians inclusive. The question then says, let omega be equal to 1 plus root 3i divided by root 3 times 1 plus I. And given this, we have to show that the modulus of omega is equal to 1 and that the argument of omega arg omega is equal to pi by 12. Finally, the question says, deduce that omega raised to the power of 18 is equal to negative y. Now, to start off with this question, let's write down the expression, and what I'm going to do is to write it down as cos alpha plus I sin alpha divided by cos beta plus I sin beta, and then multiply the numerator and denominator by the conjugate of this value right here. So the conjugate of cosine beta plus I sin beta is cosine beta minus I sin beta. So I'm going to multiply top and bottom by cos beta minus I sin beta. So top cos beta minus I sin beta, bottom cos beta minus I sin beta. Now doing so, we can see on the numerator we have to multiply these two terms, and if we distribute out these brackets, we can see we are going to get cosine of alpha times cosine of beta, or cos alpha cos beta. So we'll get cos alpha times cos beta, and then we'll get I sin alpha times minus I sin beta, which is going to be minus I squared sin alpha sin beta, and then we'll get I sin alpha times cosine beta, so I plus I sin alpha cos beta, and then minus I sin beta times cos alpha, so minus I cos alpha sin beta, all divided by the product of cos beta plus I sin beta and cos beta minus I sin beta. Now here we can see these two are the difference of squares, and therefore we're going to get the first number squared, cosine squared of beta, minus the second number squared, which is I squared sin squared beta. Now we can simplify all of this by simply putting I squared equals negative 1. If we substitute the identity I squared equals negative 1, we can see on the numerator we get cos alpha times cos beta plus sin alpha sin beta, and in terms of the other two terms, these two terms both have I in them, and if I factorize that out, we can see we get plus sin alpha cos beta minus cos alpha sin beta multiplied by I, and then everything is going to be divided by cosine squared beta, and then we can replace I squared with minus 1 to get minus 1 times sin squared beta, which is plus sin squared beta. So we have cosine squared beta plus sin squared beta. Now here we need to apply a couple of equations. The first equation is that cosine of beta minus alpha, or alpha minus beta, is equal to cos alpha cos beta plus sin alpha sin beta. So therefore this term right here is equal to cosine of alpha minus beta. Now the second term here is equal to sin alpha cos beta minus cos alpha sin beta, and this right here is also equal to the sine of the first angle, which is alpha, minus the second angle, which is beta. So this is sine alpha minus beta times I, which I'm going to write as times I at the front. So I sine alpha minus beta. Now on the bottom we can see we have cosine squared beta plus sin squared beta, and whenever you have sine squared of some angle plus cosine squared of the same angle, we know the identity sin squared plus cosine squared equals 1. And therefore on the denominator what we have is 1. So therefore we can see we get the equation we were looking for, which is cosine of alpha minus beta plus I sine of alpha minus beta. And that is the end of the first part of the question. we have shown that this value right here is equal to cosine of alpha minus beta plus I sine alpha minus beta. If you want, as a final summary, we can instead of this write something like this. We can take this over here and say cosine of alpha plus I sine of alpha divided by cosine of beta plus I sine of beta equals cosine of alpha minus beta plus I sine alpha minus beta as a final summary. Now with that, let's move on to the next part of the question. The next part says express 1 plus root 3i and root 2 times 1 plus I in the form of r times cosine of theta plus I sine theta, where r is a positive value and theta is in between negative pi and pi radians inclusive. Now for this, what we need to do is to take out the radius or modulus from each of these numbers. Now for the first number, if we consider the modulus, here we have 1 for the real part, so that's going to be 1 squared, plus, and then for the imaginary part we have root 3, so therefore we have root 3 squared, which is 1 plus 3, which is equal to 4. So the modulus squared is equal to 4, and therefore the modulus is equal to the square root of 4, which is 2. Now due to this, in order to turn this number into this form, which is the radial form, what we need to do is to divide and multiply by 2 to factor out a value of 2 from this number. So going down, we can write 1 plus root 3i and factorize out a 2 to get 2 times 1 over 2 plus root 3 over 2i. Now with this, what we can do is to substitute the known value of cosine of pi by 3 for 1 over 2 and sine of pi by 3 for root 3 over 2. So what we're going to do is to substitute that in by saying that this is equal to 2 times cosine of pi by 3 plus I times sine of pi by 3, which is in the form of r times cosine of theta plus I sine of theta, where r is equal to 2 and theta is equal to pi by 3. So that's the first value. Now considering the second number, we were given root 2 times 1 plus I, which is basically root 2 plus root 2i. Now here we can see the real part is root 2 and root 2 squared is 2, and the imaginary part is root 2 and root 2 squared is 2. So them added together gives us 4, which means that the modulus squared is equal to 4, meaning that the modulus is equal to the square root of 4, which is 2. So the modulus here is also equal to 2. So in this case as well, what we need to do is to factorize out a 2 from this thing and then take the remainder and turn that into trigonometric functions. So going down, we can write root 2 times 1 plus I, and if I factorize out a 2, we can see dividing by 2, one of the root 2's cancels, and we have another root 2 in the denominator. So therefore we get 2 times 1 over root 2 plus 1 over root 2i. And we need to know that the cosine of pi by 4 and the sine of pi by 4 are both equal to 1 over root 2 in order to substitute here. So if we do that substitution, we can see we get 2 times cosine of pi by 4 plus I sine of pi by 4, and then we can write this in the form r times cosine of theta plus I sine of theta, where r is equal to, in this case, 2 and theta is equal to pi by 4. So with that we can see we have both of our numbers 1 plus root 3i and root 2 times 1 plus I in the form of r times cosine of theta plus I sine of theta. Now after the question then said, let omega be equal to 1 plus root 3i divided by root 2 times 1 plus I. So basically, let omega be equal to the first number divided by the second number. Given this, we are asked to show that the modulus of omega or the size of omega is equal to 1 and that the argument of omega is equal to pi by 12. Now for this, what we need to do is to use all of the information we have so far, which is this formula right here, going down to this, and the value of 1 plus root 3 in the form of r times cosine theta plus I sine theta, and the value of root 2 times 1 plus I in the form of r times cosine of theta plus I sine theta. So using all of that, if we write down omega, we can see omega is equal to 1 plus root 3i divided by root 2 times 1 plus I, which if we substitute is equal to 2 times cosine of pi by 3 plus I sine pi by 3 divided by root 2 times 1 plus I, which is equal to 2 times cosine of pi by 4 plus I sine pi by 4. And we can see here the 2's cancel, leaving us with cosine of an angle plus I sine of that angle divided by cosine of another angle plus I sine of that angle. And from what we know from the first part of the question, this can be written as cosine of first angle minus second angle plus I sine of first angle minus second angle. So therefore, if we call this equation, let's say A or something, we can apply equation A and say that this gives us, from equation A, omega is equal to the cosine of the first angle minus the second angle, which is equal to pi by 3 minus pi by 4 plus I times the sine of the first angle, which is pi by 3, minus the second angle, which is pi by 4, so minus pi by 4. Now simplifying each of these down, we can see we get omega being equal to the cosine of pi by 3 minus pi by 4, which is 4 pi minus 3 pi divided by 4 times 3, which is 12, which is single pi divided by 12. So therefore we get omega equals cosine of pi by 12 plus I sine pi by 12. Cosine of pi by 12 plus I sine pi by 12, which you can see is just equal to 1 times cosine of pi by 12 plus I sine pi by 12. Now the reason I added this 1 is because it makes it very clear that the size of this number omega is equal to 1. The modulus is equal to 1. Now from this we can say, therefore, modulus of omega is equal to 1 and arg omega, the argument, the principal argument, is equal to the angle in between, this is actually pi by 12 here, is equal to the angle in between negative pi and pi inclusive that is substituted into the cosine and sine in this form. So therefore, the argument here is equal to pi by 12. And with that, we are done with that part of the question as well. Now the final part after that says, deduce that omega raised to the power of 18 is equal to negative y. Now for this, what we need to do is to apply de Moivre's theorem. Now according to de Moivre's theorem, if you have omega, or let's say we'll use something else, let's say z equals r times cosine theta plus I sine theta, and you raise it to the power of n, de Moivre's theorem says z raised to the power of n is equal to r to the power of n times cosine of n theta plus I sine of n theta. Now we are going to be using this form in order to find omega to the power of 18. So we're going to say, according to de Moivre's theorem, de Moivre's theorem, if we have z equals r times cosine of theta plus I sine theta, then z raised to the power of n is equal to r raised to the power of n times cosine of n theta plus I sine n theta. And according to that, if we consider omega raised to the power of 18, that would be equal to r raised to the power of 18, which in this case is 1. So 1 raised to the power of 18 multiplied by cosine of n theta, which is cosine of 18 times the angle, which is equal to pi by 12. So 18 times pi by 12, 18 pi by 12 plus I sine and then n theta, which is 18 times pi by 12. So this is the result we would get. Now multiplying and simplifying this down, we can see we have 1 to the power of 18, which is 1. So we have 1 times cosine of n theta, which is going to be equal to 18 pi divided by 12, which if we divide these two, we can see the common factor of 6 cancels, leaving us with 3 pi by 2 plus I sine 3 pi by 2. Now considering the values here, we can see on the outside we have 1 which you can ignore, and on the inside cosine of 3 pi by 2 is equal to 0. So we have 0 plus I times sine of pi by 3 or 3 pi by 2, which is equal to negative 1. Cosine of 3 pi by 2 is equal to negative 1. And therefore we get 0 plus I times negative 1, which is equal to negative y. And hence omega raised to the power of 18 according to de Moivre's theorem is equal to negative y. And with that, we are done with this question. Now finally, let's go up and discuss the marks awarded for this question. So at the start of the question, when you take the expression given and multiply the top and bottom by the conjugate like so, you get 5 marks, and after that, when you simplify down and eventually get the value of this expression being equal to cosine of alpha minus beta plus I sin alpha minus beta, you get another 5 marks. Now after that, when you convert 1 plus root 3i into the r times cosine of theta plus I sin theta form, you get 5 marks for that. And similarly, when you convert root 2 times 1 plus i into this form, you get another 5 marks. Now after that, when you then consider omega, see that is equal to the first number divided by second number, substitute in the values, and then simplify down to get omega's modulus being equal to 1 and arg of omega being equal to pi by 12, you get 5 marks for that. And after that, in the second part, when you then apply Demoivre's theorem, for application of Demoivre's theorem like this, you get 5 marks. And after that, when you simplify down to get that answer of omega to the power of 18 is equal to negative y, you get a final 5 marks. And with that, we are done with this question. So I hope you enjoyed. If you have any feedback or questions, post them in the comments down below. Thank you for watching and goodbye.